Hi, good morning. This is Dr. Abdul Rahim. So today we are going to discuss a topic on the matrices. The topic is about finding the inverse. There are different ways of finding the inverse of a matrix, but today we are going to discuss about finding the inverse by using the Gauss Jordan method. So what is the procedure involved in finding the inverse of a matrix by using the Gauss Jordan method? Is that we will write down the matrix capital A as non-singular matrix capital A as I identity matrix of order n into A, right? We can write down any matrix as the product of identity matrix into A. So, and we will convert by using the elementary row operations. This is converted in the form of identity matrix of order n is equals to B into A. So then this matrix B matrix will be the inverse of the A matrix, right? So that is the procedure. ठीक है, तो हम लोग आज जो है ना इनवर्स फाइंड करेंगे यूजिंग दी गॉस जॉर्डन मेथड. So today manam we will find the inverse of a matrix by using the Gauss Jordan method. What is the procedure? We will write down the given non-singular matrix capital A as product of identity matrix of order n into A. So we can write down this one. So A is equals to identity matrix into A. So both are same. So and we will convert this. इसको हम चेंज करना है, कैसे चेंज करना है? In the form of this one, identity matrix of order n is equals to B into A. ఇలాగ మార్చాలా? So by using what? Elementary row operations only, right? So let us understand this by using an example. So we will do. So let us do one problem. और problem चेद्दाम, ठीक है? एक problem करेंगे, उसके बाद आपको समझ में आएगा, ठीक है? Find the inverse of a matrix. Capital A is equals to 1, 1, 3, 1, 3, minus 3, minus 2, minus 4, minus 4 by elementary row operations, right? So we have to find the inverse of this matrix using the Gauss Jordan method, right? So as I said you earlier, so what we have to do, क्या करना चाहिए हम लोगों को? So since the given matrix is of order 3 by 3 matrix, so this is a matrix of order, so we have 3 rows and 3 columns, so therefore it is a matrix of order 3. So therefore A can be written as identity matrix of order 3 into A. So A can be written as identity matrix of order 3 into A, right? So therefore A is equals to identity matrix of order 3 is 1 0 0 0 1 0 0 0 1 into A. Okay na? So మనం ఏం చేస్తున్నాము, ఇచ్చిన మ్యాట్రిక్స్ నాన్ సింగులర్ మ్యాట్రిక్స్, సిన్స్ ఈ మ్యాట్రిక్స్ ఆర్డర్ 3 ఉంది కాబట్టి we can write down it as identity matrix of order 3 into A. So both are left hand side is equals to right hand side. So if I multiply any matrix with an identity matrix, will give you the same matrix, right? So we have written that one. So ala raskunamu. So this is A is equals to identity matrix of order 3 into A. So now what we have to do, as I said you earlier, we have to transform this one into this format. So A is equals to In is equals to A ni ela marchukovala, इस तरह चेंज करना है. कैसे? आइडेंटिटी मैट्रिक्स आना चाहिए is equals to B into A. So then B will become the inverse of A, right? So by using the elementary row operations, we have to convert the left hand side into an identity matrix of order 3. So that is our intention. हम लोगों को क्या करना चाहिए? So we have to change the left hand side to identity matrix of order n. So here we have A is of order 3, so we have to convert the left hand side into identity matrix of order 3 by using only elementary row operations. So first operation, so I want to change this one as 0, right? Our intention is to make the left hand side as an identity matrix of order 3. So therefore, this I have to make this as 0. So therefore, I will use the operation R2 is changed as R2 minus R1. So R2 minus R1, 1 minus 1, this will become 0. So that is the reason I am using this one. Similarly, I want to make it as 0 using the row 1. So I will use the operation R3 is changed as R3 plus 2R1. So if I apply the operations, what happens? You get, see here, the row 1 is not changed. So 1, 1, 3 is same. So R2 minus 2R1, R2 minus R1. So that is 1 minus 1, 0. Again use the operation R2 minus R1, 3 minus 1, 2. Then minus 3 minus 3. So minus 3 minus 3 is minus 6. Then for the row 3, we are going to use this operation. R3 is changed as R3 plus 2R1. So R3 minus 2 plus 2R1 minus 2 plus 2, it becomes 0. Similarly here, minus 4 plus 2 into 1, minus 4 plus 2 into 1, minus 4 plus 2 is minus 2. Then for this, minus 4 plus 2 into 3, minus 4 plus 6, it becomes plus 2 is equals to, same operations you have to apply for the row 2 and row 3 here also. So if I apply the operations on row 2, so that is R2 minus R1, so that is 0 minus 1, that is minus 1, 1 minus 0, 1, 0 minus 0, 0. And for the row 3, we have to apply this operation R3 plus 2R1, R3 plus 2 into 1, 0 plus 2 into 1 is 2, 0 plus 2 into 0, 0 plus 0, 0. 1 plus 2 into 0, that is 1 plus 0 is 1, right? So next step, what we have to do? Next step is we will try to make this element as 1. So what I have to do? So I have to divide the entire row 2 with 2, right? Similarly, here if I want to make it as 1, so similarly I will divide this, the row 3 with 2. So R3 divided by, right? So row 1 is same. So row 1 is not changed. So that is 1, 1, 3. So we are going to change row 2 and row 3 using these two operations. R2 is changed as R2 divided by 2. So 0 by 2 is 0. 2 by 2 is 1. Minus 6 by 2 is minus 3. Right? So then for the row 3, R3 divided by 2. 0 by 2, 0. Minus 2 divided by 2, that is minus 1. 2 divided by 2, that is 1, is equals to, same thing we have to apply for the this matrix also. Okay. Row 1 is same, 1 0 0, 1 0 0. Row 2 is changed as row 2 divided by 2, so that is minus 1 divided by 2, 1 divided by 2, 0 divided by 2, 0. Similarly, row 3 is changed as row 3 divided by 2. So 2 by 2 is 1, 0 by 2, 0, 1 by 2, 1 by 2 into A, right? So that is what we have done. Next, I want to make this element as 0. So using row 2. So I will use the operation R1 is changed as R1 minus R2. R1 minus R2. So that I can make this element as 0. So 1 minus 1 will become 0. So that is why I am going to use this operation R1 minus R2. Then this operation, I want to make this element as 0 using row 2. So I will add row 2 plus row 3 plus row 2. So this plus this is going to become 0. So that is the reason I am using these two operations. Okay. So now R1 is changed as R1 minus R2. R1 1 minus 0, R1 minus R2, 1 minus 0 is 1, 1 minus 1 is 0, 3 minus of minus 3, that is 3 plus 3, it becomes 6. R2 is not changed, same, 0, 1 minus 3. Now for R3 we are going to use R3 plus R2, R3 plus R2, 0 plus 0 is 0, minus 1 plus 1 is 0, then 1 plus of minus 3, that is 1 minus 3 is minus 2. Same, we have to apply the operations on row 1, that is R1 is changed as R1 minus R2. 1 minus of 1 minus 1 by 2, that is 1 plus 1 by 2. 1 plus 1 by 2, it becomes 3 by 2. 0 minus 1 by 2 is minus 1 by 2. Then 0 minus 0 is 0. Then R3 is changed as R3 plus R2. R3 plus R2. 1 plus of minus 1 by 2, that is 1 minus 1 by 2, that is half. 0 plus 1 by 2, that is 1 by 2. 1 by 2 plus 0, that is 1 by 2. Right? So, next operation, what we have to do. So, I want to make this element as 0 using row 3. So, I will multiply row 3 with 3 and add with this one, so that it becomes, this element will become 0. Similarly, I want to make it as 1, so I will divide the row 3 with minus 2, right? So now R1 is changed as what? R1 plus 3R3. R1 plus 3 into 0. 1 plus 3 into 0. 1 plus 3 into 0. 3 into 0 is 0. 1 plus 0 is 1. Next. 1 plus 3 into, no, 0 plus 3 into 0. That is again 0. Then we have 6 plus 3 into minus 2. 6 plus 3 into minus 2. 3 into minus 2 is minus 6. 6 minus 6 becomes 0. Right? Then there is no change in R2. 0, 1, minus 3. Then R3, we are dividing R3 by minus 2. So 0 by minus 2 is 0. 0 by minus 2 0. Minus 2 by minus 2 is 1. Then we will apply the same operations for this matrix also. R1 is changed as R1 plus 3R3. R1 plus 3R3. 3 by 2 plus 3 by 2. That is 6 by 2. It becomes 3. Then we have R1 plus 3R3 minus 1 by 2 plus 3 by 2. Minus 1 plus 3 is 2 by 2, that is 1. 0 plus 3 into 1 by 2, so that is 0 plus 3 by 2, that is 3 by 2. R2 is not changed, minus 1 by 2, 1 by 2, 0. So we are going to change R3, dividing by minus 2. So 1 by 2 divided by minus 2, so it becomes minus 1 by 4. 1 by 2 divided by minus 2, again it becomes minus 1 by 4. 1 by 2 divided by minus 2, again it becomes minus 1 by 4. Right? So now the only one thing we have to make this element as 0. So how to do that one? We will use the operation R2 is changed as R2 plus 3R3. I will use this row 3 to make this element as 0. So R1 is same. So 1, 1, 0, 0, 0, 0. Now I am changing R2 only. R2 plus 3R3. R2 plus 3R3. 0 plus 3 into 0 is 0. 1 plus 3 into 0 is 1. Minus 3 plus 3 into 1. Minus 3 plus 3, it becomes 0. Now this is same, no change. 0, 0, 1. So we will apply the same operations for this matrix also. R2 is changed as R2 plus 3R3. R1 is same, 3, 1, 3 by 2. R2 is changed as R2 plus 3R3. Minus 1 by 2, minus 3 by 4. So we will get here minus 5 by 4. Then here R2 plus 3 R3. So we'll get here minus 1 by 4. For this one, we'll get minus 3 by 4. So R3 is same, minus 1 by 4, minus 1 by 4, minus 1 by 4. So now you see here, so we got here identity matrix 1 0 0 0 1 0 0 0 1. So this is an identity matrix of order 3. So this is, we have changed it as identity matrix of order 3 is equals to B sub matrix into A matrix. So now this matrix is nothing but it is the inverse of the matrix A. So therefore, A inverse is equals to this matrix. So 3, 1, 3 by 2, minus 5 by 4, minus 1 by 4, minus 3 by 4, minus 1 by 4, minus 1 by 4, minus 1 by 4. So this is the procedure to find the inverse of a matrix by using the Gauss Jordan method, right? So let us recap. We have to write down the given non-singular matrix as a product of identity matrix of order of that of A into A, right? So we will use this one. We will write down the given matrix in the form like this, and we will try to change it in this form, right? Change it in form. We have to make the left hand side as an identity matrix by using only elementary row operations. ठीक है, हम लोगों को जो नॉन सिंगुलर मैट्रिक्स दिया गया है उसको इस फॉर्म में लिखना है और इस फॉर्म में चेंज करना है by using only elementary row operations. So once we reduce the once we make the left hand side as an identity matrix, so then here we will get B matrix. So this B matrix will be the inverse of the matrix given matrix A. So therefore A inverse is equals to this matrix, right? So this is the procedure. Thank you for watching my video. Please hit the like button as well as subscribe to my channel for watching more videos. Thank you.